Okay, using the electrical calculators. Before I start even, guys, I want you to take that calculator out of the cover that you have. Slowly, gently. If you take it out of the cover, you need to be aware of a very important thing. Are you guys there? When you take it out, it looks something like this. Look at the back. There's a little button that says reset. Can you guys see that little button? If you stick a pin or something in it, you reset your calculator. If all hell breaks loose and everything is not working good, all what you have to do is just reset your calculator. That's only extreme cases. You don't have to worry about it. Cool? That's number one. Number two, right above it, can you guys see that little chip? Everybody can see this chip right here? This is where when they update the 2014, don't open it. When you update to the 2014, that's where they give you, Phil, my friend, they will order you a tiny little chip, that little chip, for $13 or so, and you unplug this, put the new chip, but you are updated to the 2014 code. Cool? So you don't have to buy a new calculator. Are we, everybody's okay with that? They will tell you, can you see it, Chris? They will tell you when you, before you unplug this, and later on you'll know, they want you to take the battery off. Take the battery out, and then you plug it in. But you don't have to worry about this one until 3 years from now. Okay, everybody see that? The back, reset and changing to a new code, 2014, and you take the battery out before you change this chip. And you put the chip in, then you put the battery in, and off it goes. So you don't have to worry about that one for 3 years. Cool, everybody's okay with that one? All right, now let's go to your calculator. Looks exactly like the one that you have over here. The first thing, guys, the first and most important thing for you, do you see the on-see that? Clean. Before you do any operation, hit this always twice. Get into the habit of hitting this twice. If you hit this twice, it will delete everything that you put in this calculator. So every time you start a new process, hit it twice. Cool? Everybody's okay with that one? All right. Make sure you turn it off. Always when you're done, turn off your calculator. Can you guys see that? Turn on your calculator, off your calculator. After you're done, turn off your calculator before you shut it down. Everybody's okay with turn on, off? Cool? All right, that's the easiest part. Okay, the first, so that's is turning on and off. And this one, you hit it twice every time you start a new operation. Parallel, series, disconnect, switch for motors, and so forth. All right, I want you guys to look at the default here. Can you see the default right here? What does it say? 3-phase, 60 hertz copper. This is what the calculator, can you guys see that right here? 3-phase, 60 hertz, 60 copper. Everybody's defaulting to this. That's what the calculator default to. So if you have single phase, you need to change this. If you are using aluminum, you need to change this. Cool? All right, so that's your default. The second thing that I need to know, how do I know that this calculator is using 2011? How do I know, guys, that this calculator is using 2011? Okay, this is, you're going to go set, hit set, and go preferences. You should get NEC 2011. That will tell you that you are sitting at 2011. I believe if you hit it another time, set, hit it one more time, it will continue to 2011. We're defaulted to 2011. Everybody's okay with that? Huh? One more time. Hit set. Can you guys see it? Can you see my mouse right here? Set. And that division sign. Let me just tell you a sneaky thing about this calculator. Everything in the blue, I don't see it on the blue here. Everything on your calculator on the light blue, can you guys see the stuff in the light blue? In order to activate anything on light blue, you have to hit set. That's very important. Like other calculators, guys. Everybody can see that? Everything to activate anything in the blue, you have to hit set. Okay, so if I'm going to go hit preferences, so I know I'm sitting at NEC 2011. Everybody's okay with that? NEC 2011, we're cool. Good, Chad. Now, what if I want to change to 3-phase? So I know I'm set 2011. One other thing I found very important is clear everything. If all hell break loose, remember that reset button at the back? That's for the extreme cases. There's one button here. If you added voltages and currents and you have no idea what you bought, clear all. This comes very handy. I found it. Set and hit the X. Clear all. Clear all will default your calculator to the following. NEC 2011 3-phase 60 cover. 60 degree cover. That's clear all. So when you start changing later on, guys, as we move on, we start changing the ambient temperature and the derating and all this good stuff. And you have no idea. You're going to go back to the default. So clear all, set. Can you guys see set and clear all? That will get you back to where the start point, which is 2011 3-phase cover 60 hertz. The 60 degree is the default of your. Everybody knows what the 60 degree is. The 60 degree column in 310.15 B16. That's your default. In the default the default is 310.15 B16. This is where the 60 degree column is coming from, as well as the cover. CU. Okay. Any question, guys, about that? All right. So let's go. Let's go since we're here. Let us go and do a few things. First of all, I want you guys to change it to 3-phase. Go set, and do you see where 3-phase is? The number 3. Set number 3. That will change your calculator into default to 3-phase. Now you're doing 3-phase system. Did you guys see that? Set 3. That will get you to 3-phase. Okay, now let's go change to aluminum. Set 4. Can you guys see set 4 right above it? CUAL. That will change me to 3-phase 60 hertz aluminum. God forbid we use one of them. Aluminum is good, but Chad is an engineer, likes copper. Okay, let's go one more time. Set single phase. I change it to single phase 60 hertz aluminum single phase. Let's go set copper. So I'm sitting right now at single phase 60 copper, single phase 60 copper. Everybody's okay with that? So if you guys go 7, 4, and 6, if you hit set at any one of these, right above it, it will tell you how to change it to single phase, copper, or aluminum, or the temperature. All right, I want you all guys to go set 3-phase, all of it. So I'm set at 3-phase, and I want to go set to copper. So everything is set at copper, and I want you to set 75. Can you guys see where it's set 75 right here? Where is set 75? 7. If you set 7, it will give you 75 degree column. Can you set your calculator to 3-phase 75 copper? Okay, and very easy. You go to set copper, which is 7, set 3-phase, and if it was aluminum, like this, 3-phase aluminum, set number 4 will get you 3-phase copper. So I'm sitting at 3-phase 75 copper. What does 75 means? I'm defaulting now to the column 75 as I size my conductor. So you have to be very aware when you put 75, you're telling the calculator size everything that I put right here based on the 75 degree column. Remember how we were using the 75 degree column, guys, in examples? Okay, everybody set at 3-phase 75 copper. Okay, let's do a little thing. So this becomes, sitting up this way becomes big deal when we size the conductors, really, and so forth. Here's what I want you, I'm looking at your test, guys. I'm going to do question number 2. What is the true power of a 10 amp circuit operating at 240 with a unity power factor? Let's do this problem in the test on this calculator. So before we do anything, I want you to go erase, hit twice. So clear the memory. Hit the clear here twice. Everybody right here, hit it twice. We're clear. Since I'm not sizing anything, it doesn't matter if I'm 3-phase or single phase, but make sure you're defaulted to 3-phase 75 copper. Just leave it this. Okay, here's the question. What is the question would be? The question here would be, my friends, as when you need the calculators to do it, I have a question of the current. What was the current? I have a current of 10 amps, voltage. What's my voltage? A voltage of 240 volt, and a power factor of 100%, unity. 100% power factor. What am I asking you to do I'm asking you to find what is the true power. Find true power. You guys remember what true power equal? True power equal the current times the voltage times the power factor. So this should be 10 times 240 times 1, right? This should be 2400, right? Watt. Because it's true power. Okay. Any question about this? That's like the problem that you just did. Very simple one. Let's do this one with the calculator. Actually, the power of this calculator, guys, is not this simple calculation. It's sizing conductors and disconnects and overcomputation device. But let's just do this one. Okay, I want you to follow with me. What's my amp? So this is how this calculator works. It took me a while to get used to it. You have to type the amp and hit amp. So look what I'm going to do. I have 10 amps. 1, 0. And I'm going to hit what? Where's my amp? But this is single phase. Before I do anything, I'm going to clear it. Since this is single phase, right? I don't want it to be confused with three phase. I'm going to go change myself to single phase. How do you guys change single phase? Set 1, single phase. Okay, because that problem, does it have a three phase in it? Single phase problem. Okay, set single phase. Everybody is set single phase? Okay, let's put the amps. Start with your amps. 10. I type 10 and hit amp. See where it says amp right here? Hit amps. What I told the calculator, I said, I want you to store a 10 amps in your memory. Just store it for now. Cool? All right, let's go to the voltage. Forget about what I did. Just hit 10 and hit amps. I want to go to the voltage. What was my voltage? 240. And I'm going to hit volt. So I'm telling the calculator to store a voltage of 240 in your memory. I stored the amp and I stored the voltage. Okay? Power factor. I want my power factor. What's 100% power factor? 100. The power factor I have to hit. Okay, did you type a power factor? Did you guys input the 10 and 240 by hitting the amp? Okay. Now type 100 and hit set power factor. My power factor is 100. Set power factor. That will get you. Do you guys see why the power factor is usually set power factor? Okay. Set power factor. So I put the power factor, I put the amps, and I put the voltage. Now I'm ready to get the answers. All what you have to do, input. You're just inputting info. Now I need the watts. See, you see where it says watts right here? Hit the watts. 2400. Did you guys get 2400? That's exactly the math that we did right here. 2400. Isn't that cool? Right? Don't make me hungry by eating in front of me. Does that make sense? Now if you put three phase here, it will do the calculation based on three phase and will multiply by 1.73. That's why you gotta understand the single phase, three phase is a big deal. Cool? Everybody's okay with that one, guys? Very easy. Everybody got 2400 watt? Okay, it even gets better than that. What if I want the volt amp? I don't want the watts. Now remember, the power factor is the same, Phil, so the power should be the same. So go hit volt amp. Can you guys see the volt amp right here? Hit volt amp. Now it's volt amp the same, 2400 volt amp. Hit watts, 2400 watts. Hit volt amp, 2400 volt amp. Right? Piece of cake. Now, have you known that? You don't even have to use calculator anymore. And by the way, for my test, if you know how to use it, by any means, please do it. Let's take another example related to the same topic. I'm going to go change this one, guys, into 100 amp. I'm going to change this one into 480 volt. I'm going to change this one into 90%. I'm going to change the phase into three phase. Okay, I changed 100 amp 483 phase power factor of 90, and I need to find now. Remember, this is not going to apply now, so I'm going to go erase this. I need to find the following, and you guys can do that faster than I can erase this board. I need to find the true power and the apparent power. I want to remind you guys If it's a three-phase, the true power would be 1.73 times V times I times power factor. And the apparent power would be 1.73 times V times I. Okay? And I need to do the calculation for that. Let's do the calculation directly, guys, before we use the calculator. Or shall we use the calculator and then we verify it? Let's do the calculator. Now remember, Zach, before I do anything now, what do I need to hit? I'm starting a new operation. Clean twice. Hit clean twice. Bam, bam. So that will clean my calculator, get it ready to run. I basically got the memory out of that calculator. So clean it. Everybody hit on or C twice, right? C twice to clear the memory. Okay, let's go. Why don't you guys put the amps first? 100. And you're going to hit the amp. Cool? Everybody's okay with that? Let's go to the voltage. The voltage is 480. I didn't do one big step, guys. Remember? The voltage is one big step. Okay. What's the power factor? 90. And set power factor. So I put the amps, I put the voltage, I put the power factor. Look at my calculator, those still defaulted to what? Single phase. Oops, Chad. I'm going to go change my calculator to three phase because we're a three phase system. I'm going to go set, where's my three phase? Number 3. I converted my calculator to three phase. Now I'm looking at three phase system and I inputted all these good stuff. Cool? Were you guys able to put them all? Okay, let's go. Now, we put the amps, we put the voltage. I believe the amps should be here. If you hit the amp, you should see the amps that you put. If you hit the voltage, you should be the voltage that you see, that you already did. If you hit set and power factor, you should be able to see the power factor that you did. If you forgot what you did, the latest. Now, I'm going to go to the watts. I'm going to go find the volt amp. All what you have to do for the volt amp is hit volt amp. It's 83.1, it's 83, almost 83 kVA. So this is the volt amp. This one should be 83 kVA. Very close to 83 kVA. DJ, you can sit. We're doing the calculation. You can jump with us. Okay. So this should be 83 kVA. I want somebody to verify that this is the answer, guys. Okay, so the answer for this one is 83 kVA. Let's go the watts. Find the watts. Here's my watts. 74.8. My watts is 74.8 kW. Who's going to be my A student who's going to verify these numbers with the calculator?
Should I use yours?
You going to use that one? Okay. Yeah.
74.824.
So 74.8 kW and 83 kVA. Did you guys get the same numbers? Isn't that cool? By putting the voltage and the current and the power factor, I got the true power and the apparent power. Now kiss your calculator goodbye, the other calculator now. Isn't that cool? But you don't have to do the math. You don't even have to know what the formula is. The formula is already programmed in the calculator. Any question, guys, about this? Any question about this? Yes, sir.
You want to go in and change the amps? You just insert the numbers and press the amps.
Yes. But before you start a new operation, so now I'm done with this operation, I verified it, right? I always go hit twice the delete here. Once, twice. I hit the delete. So it got rid of the amps, and see if you hit amp again now, there's nothing under amp. There's nothing under voltage. Oops. Hit voltage and volt amps. So you need to hit this one twice so it clear the calculator for new operation. Any question, guys, about this? Did we get the same calculation? Okay, so that's very powerful. Tao, my friend, the single important thing is to understand, it took me a while, it's like your Excel. You guys remember Excel? Chris, you did a great job with your Excel sheets. It's like Excel. You put multiple cells and the last cell will be calculated. And here's the fun one. If you guys, you can put any one of these and you can put, how many variables here? That's the fun part. I have 1, 2, 3, variables. The three-phase you have to pick 5 variables. Take this. You can put any 1, 2, 3, 4, 5, any 4 out of these 5 variables and get any 4 and get the fifth. For example, I can put the AP, the TP, power factor, and the voltage and find the current. Did you guys hear me? I can put the TP, power factor, volt, and I and get the AP. I can 5 variables. I can get, if I input 4 of them, I can get the fifth. It doesn't matter which one is the fifth. So for example, if I know the watts, I can just put the watts, input the watts. If I know the volt amps, I can put the volt amps. If I know the amp, I put the amp and the voltage, and I need to know the power factor. Hit set power factor, and we'll get you the power factor. So let's take another example, guys, with this. Any question about that? Any question about it? Take a snapshot on that. Okay, let me see. Move it to the next page. Okay, take this. So that was question number 2 that we just did for you. Let me do question number 3. What size transformer is required for 240 100 amp single phase load? 240 100 amp single phase load. Take this. Size transformer. I need size transformer. So what is the size of transformer? AP. I need the apparent power. Find the AP. If the I is, what's the I? The I is given as 100 amp, and the V is given as 240, and apparent power, and it's a single phase system. I'm telling you, it's single phase system. Okay, did we hit this twice, guys? Now the first thing you need to do is you need to set yourself, it's set at 3 phase. I need to go back to single phase. So set single phase. Here's my single phase. Cool, everybody single phase? All right, let's go to the amps. What's my amps? 100. Hit 100. Here's my 100. An amp. Perfect. I got my 100 amp. What's my voltage? 240. 240. What's my volt? Here's my volt. 240. Okay, so what do I need? I need apparent power. What's the apparent power? It's the VA. I'm not asking you. I didn't give you the power factor. I care less about the power factor. So I need just the apparent power. Here's my VA. 2400. Is that true? Is that what we do? 2400. Done. Done. But make sure you set for single phase. Now here's mistake fell. People will leave the 3 phase there. Component. This calculator, guys, it's not supposed to replace your being a professional. You're the professional. You have to understand, are you dealing with single phase or 3 phase? With single phase or 3 phase? You know? Okay, here's question number 2 done. Question number 3. Okay, I'm going to do question number 4. Any questions about this? So this is number 3 in the question that I give you, at least version A. These are version A. We did number 2. Let me do number 4. Question number 4 that I gave you guys. Question number 4. What size transformer is required for what size transformer is required for 30 kW 3-phase load with 85 power factor? So here's what they're asking you. Volt amp is given as 30. My volt amp is given as 30 kW. DJ, this is recorded, so you can get that one too. 30 kW. Phase, I have a 3-phase system. Very important to know the phase. And what else do I have? 3 phase, and I need a power factor of 85. And I have power factor equal 85%. And what do I need to find? A transformer size. Transformer size, guys, always we size a transformer in AP. So I'm asking you apparent power. Find the apparent power. So I'm giving you, I'm sorry, this should be watt actually. This should be watt. And kW should be watt. The true power. The true power. I'm giving you the true power. It's a 3-phase, giving you the power factor. Find the apparent power. Let's go do it. So the first thing you do, Rob, what do you do with the clear? Hit once, twice, clear it. I'm going to go to my 30 kW. Here's, look at that, 3030.
You gotta change your page.
Thank you. I'm going to change my phase. I can do it, but it's a good idea always to do it at the beginning. You're absolutely right. Set three phase. Always get yourself. So I set my calculator three phase first. And I hit clear, 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 clear a couple of times to clear it. Three phase, right? Perfect. Now, look what I'm going to do with the 30 kW, guys. Here's my 30. You have two options. Either you put 30,000, or you can hit 30, and can you just see where's K? Kilo. Can you see kilo? So here's a 30 kilo. So just type 30 and hit kilo. But it still doesn't know what 30 kilo of what, Chad? 30 kilo dollars? Or bananas? 30 kilo, right? That's up. Chicken, thank you for reminding me of my friends the chicken. 30 kilowatt, right? It's watt. So hit watts. So it assign a 30k watt to this load. Cool? All right. Now I inputted the 30. I need to go to the power factor. So what's the power factor? 85. 85. Perfect. And it's 85 and it's a power factor. So you have to go set and hit the power factor here. So it's set at power factor 85. Cool? Three phase power factor 85. So what do I need? Only two values I need here. What do I need to find? Apparent power or volt amp. So what do you think the last thing where is a volt amp? Here's my volt amp. 35.3K. Is that true? If you use your calculator and divide the formula for this, guys, as you and I know, the formula is apparent power equal true power divided by power factor. So if you take the 30K divided by 0.85, 3, divide by 0.85, you're going to end up with 35.3, which is right here. You end up with this value equal 35.3 kVA. Done. See how easy that's and nice and clear cut.
Does it have any rounding?
Hi. I suppose you can. I think if you hit this, it gets the answers. Oh no.
You can get like code numbers, you can code reference.
Yeah, when we do the code, this is just calculation. So you have 35K, and everybody knows. I hope you guys understand when I say 35,000.3. I'm doing approximation right at this value here, right at this value. Any question, guys, about this? Isn't that cool? Am I the only one who's excited here?
No, I am not.
Okay. What's going on here, guys? Okay, here's question. These are just questions on the test that we did today that you can easily do on that one. So we did 4.
All right, so.
But equivalent, okay, 3 phase. What's the output into for? Okay, number 5 was an interesting. Yes, you can write it. All right. So let me do number 5. It's really interesting, guys. Okay, let's move one more step. Let's move you up to here. And my intention is to go, as we go through, I'll do more of these stuff. Let's do question number 4 on this calculator. Number 5. Here's what number 5 says, guys. The output is 200 kW. The equipment is 88. Let's write the requirement first. I have a system. I have a system. My system true power out. I'm giving you the true power out 200 kW. Okay? And efficiency, the efficiency of this system is 88%. You guys have just done that. What are the input amp if the voltage is, I need I input N, that's what I need. And if the voltage system is, the voltage is voltage equal 208 volt, and the system is 3 phase. And I'm not giving a power factor. If I'm not giving a power factor, what do you think the power factor is? Unity, unless you are told otherwise. So I'm not giving a power factor, so my power factor equal 100% because I'm not giving it. That's an interesting if we can find this one on the calculator. Find this one on the calculator. Interesting. Okay? So the formula that we need to use, guys, the formula that we need to use is I input, and I told you we can get this one from DeWalt, all these formulas, and we find it. So I know the power factor, there you go, direct current, single phase, three phase, and I need the efficiency. I need what amps when horsepower is needed. So I need, here's what I need. I need the current input, so I need the voltage. I need, what do I have? Watts. Do I have the watts here? I need the watts, which is kW. That's my true power divided by the watts. The true power divided by 1.73 because it's three-phase system. The voltage times power factor times miss efficiency. This is the formula that we need to do. This is the formula that we need to do. We take the true power, which is the kW, the true power out, divided by the 2 power n to give us the efficiency, and we manipulate the formula to give us the current input. This formula, guys, it's in page 1-4 DeWalt. 1-4 DeWalt. Did I do it right? The true power out divided by the 2 power n give us the efficiency. So if the efficiency is here, out over n 1.6 volt and the power factor. Yep, perfect. Okay, so this is what I need. This is the formula. I plug in everything in this formula to find I. Let's see if we can do it on the calculator. Let's see if we can do this one in the calculator. Okay. All right, I haven't done it before, so it'll be an experience. So what do we do first? Clear, clear, clear. Am I in three-phase system, Phil? Am I defaulted to three-phase system? Yep, I'm defaulted to three-phase system. Okay, then maybe I should wait a little bit. Any question, guys? A true power, when we have an efficiency system, when we have an efficiency in the system, okay, there you go. When we have an efficiency in the system, here's my true power in, here's my true power out. And if you divide the n on the out, get you the efficiency of the system. True power in, true power out, give the out over the n, get you the efficiency of the system, and then manipulate the formula, will get you the current that's coming into the system. I'm asking you for the current, that current, input, IN. Okay, let's see if we can figure this out. Okay, so delete, or clear. I need 200 kW. So here's my 200, 200, and I want to hit K. And what is this value? kW, right? So here's my watt. Everybody's there? kW. Here's my watt. I put 200 kW. That's my input. Let's go to the efficiency. My efficiency is 88. You can see where F here, everybody can see F is right above the HPTH. So I'm going to go set efficiency. So I put an efficiency of 88. See where I put my efficiency? Everybody can see the efficiency right here. Anything in blue, DJ, you have to hit set to reach it. Like any other calculator, guys, like inverse. So I have an 88 efficiency. Okay, so I got the efficiency. The current, I have no idea what the current is. Let's put the voltage. What's my voltage? 208, and I hit volt. So I got my voltage to 208 volt, right? My system is set at three-phase. You can see that three-phase right there. My system is set at three-phase. What else? Power factor. I need my power factor. Here's my power factor. 100. It's 100% power factor. And set watt. Set watt or set power factor. Now I put 100% power factor for my system. Look how nice that is. I inputted all these values. Right? Is there anything else I need to input? All my values.
About the 200 kW.
I did the 200 kW at the beginning.
Oh, okay.
Put them in, the 200 kW. I put the 200. So here's my input. I put this, and I put this, and I put the voltage. Three-phase system is already defaulted to, and I put my power factor, and I need to find this value. So amp, right? So if I hit amps, and guess what? 555. Did you guys come up with something similar to that? Anybody came up with 555? See how easy that is, Phil? If that wasn't a test, you could have finished it in 10 minutes, and the rest of the class went outside to have fun with your girlfriends, or with your friends. 55 amps, 555. So the amps here equal 555 amps. Isn't that cool? Who cares about this amps? Some of you might, we're not doing this, guys, for the sake of mathematical exercise. We're doing it later because we're going to be sizing based on these amps, conductors, and so forth. But I'm just giving you the basics, how you can do the basics right from this formula. Any question, guys?
Why did these guys get it so easy?
You can repeat, DJ. Okay, I'm going through the test, guys. So, I don't have neutral conductors for three-phase formula. I don't have this one, or maybe I don't know how to use it yet. Okay, how many? Number 7, it's really not hard to find number 7, which is how many 20 amp, 120 circuits are required for 5200 watt luminaire with a power factor of 90. It's hard to do this one directly from the calculator. You have to manipulate it, find the apparent power. We can attempt to do that one in the calculator. It wouldn't be my first choice. I'm gonna go into the last one, number 9. Parallel conductor, parallel resistors in parallel. I'm gonna do resistors in parallel. Number 9. What is the total resistance of the following resistors when connected in parallel? R1, R2, and R3. Everybody knows how to do this in a calculator. Okay, so let's take a snapshot on that baby, or move to next page. Okay, grab this one. Okay, can you guys hit clear? So we are clear. Here's my question for you. What's with Kim Kalhammer? That's my wife. Now what? Okay, question number 9. I have 3 resistors in parallel. Basically, here's my resistors. I put them in parallel. I know you guys second year, so this was a quick exercise of mental exercise. And my resistors were 5, 10, 15. I have a 5 and a 10 and a 15. And I'm asking you to look right here, group these babies together, and get me R total equal. Find the total resistor for 3 resistors in parallel. Find the total resistor for 3 resistors in parallel. 3 resistors in parallel. Okay, we're cool? Everybody's okay with that? Look how nice we're going to do. 3 resistors in parallel. Okay, so we cleared it. Since we're doing resistors, it doesn't really matter if it's single phase or 3 phase here. We're just doing resistors in parallel, as basic as you can get. This is the least important things in this calculator, what I'm going to do right now, honestly. The most important thing is what we're going into sizing the power factor and the disconnect and so forth. Okay, take this. So I'm going to take, can you guys see my 5 here? Everybody can see my 5. So hit 5 and set and store. So you just told the calculator I have a resistor 5 ohm in parallel. So one more time, I'm going to go clear. I'm going to go, my first one is 5. Here's hit 5 and then go set and see if you say set parallel resistors. Right at the top here is say parallel resistor. So you put 5 resistor in parallel with what? With nothing yet. Okay, so here's the first one. What's the second one? 10. So I'm going to go 10. 1, 0. Set parallel resistor. Look at that. It calculates 2 resistors. It did calculate these 2 for you. Right on the spot. It took these and calculated the total resistor for them. Right on the spot. Can you guys see that? Tell that to Ryman now. He's going to be jealous. So it calculates these two right on the spot. Now, but I'm not done yet though. I need one more. So what do? I need 15. Here's 1 and a 5 and a set and a parallel. And here's your total. So it took, now this one is all of them together. So your answer would be 2.72 Mr. Ohms. Did you guys come up with something similar, the one who were calculating it?
Yeah.
Isn't that cool or what? Any question guys about this? So this is basically the least, this part is the least attractive part, the least attractive part. I'm not sure if it does the inductance. I don't see inductance here and inductance. I haven't seen inductance, like finding XL and XC. You know how to, you take the 2 pi times F times C, 1 over 2 pi FC, or 1 over 1 times, or 2 pi times F times L. That's, any question guys about this? In parallel, conductors in parallel. Is that enough for today? Is a good start? Okay, why don't you guys read through that, and as we continue doing, I will continue. The most important thing is coming, is how to do derating conductors with this calculator, how to do voltage drop with this calculator, how to do size. I want to bring to your attention, guys, parallel conductor. Look at that. You have parallel conductors, grounding and bonding. You have inverse type overconduction device, overload, disconnect, magnetic starters, conduit size. All of these, thank you guys for buying it and having it. All of these will be done on this calculator. Is that good?
Yeah.
That help?
Yeah.
A good start. So when you're done, what do? You hit the button before you do off. Done. Thank you, Chad. And we close this for me. And off it goes. Thank you. That will be lesson number 1, my friends. Okay.